Okay, it's recording. The little number wasn't showing up and I got scared. Okay, so today I'm going to be talking about Chapter 10, and Chapter 10 is all about different experiments. And I'll probably just be going over about like the first half of this. So first of all, the pros and cons of experiments. So on the pro side, it determines causal relationships, which if you don't remember what that is, it determines cause and effect essentially. And going hand in hand with that, we're asking if A, our independent variable, causes B, our dependent variable. And cons of this is ecological isomorphism, and the lack of this is when the experiment doesn't match what's actually being studied. So the textbook gave a great example for this, and they said, say you bring people in to test whatever you're testing. In this case, we'll just say like, we're going to bring someone in to see how they shop online. They gave like, to see how they watch sports, see how they shop online, and I think like how they work together as a team. So say we're like focusing on how they shop online. They're going to shop differently at home on their couch at like 2 a.m. They're going to shop differently online then compared to when you bring them in and someone's studying them. So that can be kind of an issue, just because you're not going to get 100% accuracy. Okay, so ex post facto. So this is when someone's observing the observes after the fact rather than setting up an experiment beforehand. And the textbook gave another great example for this that I honestly don't remember. But go check that one out. And one that I thought of was studying smokers' lungs after they've smoked and comparing it to healthy lungs. I'll talk about this like a little bit more later too, but you can't really force people into smoking. You can't experiment with that just because that's not cool. So you're going to look at them after they've already done all that and then see what happens. Okay, so field experiment is what you're going to hear about a lot more, and it's also known as a simple observation. And a lot of times, you know, like the word simple is in a phrase, and even though it says simple, it's usually not. This one actually is, so that's happy. Okay, and this is just manipulating a variable and observing the results. And you're going to need at least 2 groups for this, and one of them is going to be control group. And you're going to need at least 2 conditions. So that's like 2 different groups with different conditions. So say that you're testing a new medicine. You're going to look at our study condition 1, which will be people who are getting the drug. And then you're going to look at our study condition 2, which is people who are not getting the drug. And we're going to look at the results for both of those. Okay, and so that kind of goes into basic experimental design. And so first we have our 1 group pre-test, post-test design. And this is actually the only one in here highlighted. So in here we have 3 steps. So we're going to have our baseline observation, which is known as O1. The exposure to experimental condition, which is known as X, and the post-experimental observation, which is known as O2. And altogether it's going to be written as O1, X, O2, so don't confuse that X as a times. That's just saying what you're exposing to. That's just your condition. Then we're going to look for a difference between the baseline and post-experimental observations. So something I thought of this is actually like a little bit of a rant of mine. But so I have this class right now that I was complaining to my husband the other day. I'm like, I just feel like I didn't learn anything in it. So I'm like, well, what if there is a way to test that? And there is. So say that I take a math test or whatever before taking the class, and that is my baseline. Like that score would be my baseline. Then I take the class, do all that jazz. That is my experimental condition. And then I'm going to take that same test again, and this will be my post-observation. And if there's a significant difference in my scores and other people who participate in this and their scores, if there's an overall significant difference, then it's like, okay, I know that class actually was helpful. But if there's not, then, class is not helpful. So anyway, that's just an interesting little thing. Okay, Designing for control. So this is two group pre-test, post-test design. So this is super similar to before, but this time we're going to have two groups. And one group is going to be the control group, so we're not going to give them any exposure to the experiment. And the other group is going to be exposed. And a lot of times with like medical trials, the people won't know what group they're in, just because they want to see like, okay, does this treatment actually work? Does this drug actually work? And a lot of times the researchers or people administering won't know either until like way after, which would be double blindness. Okay, so the same kind of deal goes forward for as far as administering this. So we'll have our baseline, our experiment, or no experiment, and our post-observation. And this is going to be diagrammed just about the exact same, except now we're adding the O1, O2, and notice that there's no X in there. Okay, so designing for random assignment. So random assignment is best for uncontrollable variables in certain situations. So the textbook gave an example of this. Talked about a professor wanting to measure IQ scores in a college class. So if you try to do that, like say you're comparing two groups, there are a lot of other things that could come into play. You could look at like different internet access levels, motivation of the students, their resources, time, age, you're in college, lots of things in there. And so random assignment is exactly what it sounds like. You're going to be randomly assigning different people to groups to see if there's any change in your variable, which plays into two-group random assignment pre-test, post-test design. So this would be like a professor splitting the class into two groups. So say there's like 50 students in the class, and you're going to randomly assign students to group 1 and group B. And group 1 is going to have a study guide, group B is not. So the professor wants to make sure that these groups are even and totally random, so that way you don't have group A with like a ton of seniors or like super motivated people, and then group B with just like people that don't want to do anything, or they're all freshmen or something like that, because then you're going to get really swayed results. Okay, so next is our Solomon for group design. And Dr. Wing talked about this in her lecture, how it's very rare, very sophisticated, and very expensive. So this one, our first two groups are going to be the same. I had to make this little chart for me to see it visually. So our first two groups will be the same. They're both going to pre-test. One is going to get the experiment, and they're both going to post-test. But then 3 or 4, they are not going to pre-test, and then 3 will get the experiment, and they'll both post-test. So this is basically just saying, like, okay, is the pre-test affecting post-test at all? And that'll just make sure that your experiment is even more accurate and your results are even more accurate. Because, and then like as far as the expenses go, you know, like of course this is going to be a very accurate design. But if you're looking at like, okay, we're going to need a ton more people, say that we're like giving these people some money for participating, that will get expensive. Then if it's a medical thing, you're going to have to find some way to afford even more treatments or drugs or whatever. So again, expensive, but super nice, but expensive again, so not very common. Okay, so I think this is the last, no, it's not the last slide. So time series analysis, experiment time periods are often short, so we can't know if the results are going to be accurate in the future as well. So time series analysis is the solution for this. Experiments are conducted many times over different periods, and this just checks to see if the result is stays stable over time. So an example that I thought of for this is like COVID vaccines. So as of now, you know, COVID vaccines are for the most part working out pretty well, but we don't know if they're still going to be effective come like 5 years or whatever. So say I want to test that, so every like 2 years I would conduct an experiment to see if the vaccine's still working, and say a few years pass, and it isn't working anymore, then that could show there are other variables in play in either that current time or now. Okay, this is the last slide. So factorial designs. So for this one, you're going to have two things that you need to make sure that you know the difference between. You're going to have multivariate analyses, and that is studying the relationship between 3+ variables. So this is not doing an experiment. This is the same thing like the other thing that we mentioned earlier, ex post facto. So same thing with that. Like, say you want to know about smoking, you can't really do an experiment with that, and you can't do it with drinking either. And so say we're looking at how do age, smoking habits, and drinking habits play into cancer. So at this point, we're going to be looking at 4 different things, asking 4 different questions. You know, how old are you? What are your smoking habits? What are your drinking habits? And do you have cancer? And we could see a lot of different relationships between those 3 or 4 things. Okay, so then the next thing that you need to know is factorial designs. And this is experimental designs that manipulate 2 or more variables. So this is experimenting. And notice how now you're only looking at 2+ variables. So, say like an example of this is, how do the amount of water consumed in a new drug affect depression? So this could be really interesting to look at, because like you can't play with water consumption a ton, but you know, you still have to stay in a safe range for the participants. But it's a lot more legal, and you still have a good bit of leeway in there. So, and you can manipulate those things. You can definitely manipulate the new drug. And that's it.